Hey guys, welcome back to the second part of the tutorial. If you haven't checked out the first part yet, please go check it out. But just for a quick reminder, this is the visual we are trying to create here in this tutorial. It's a visual I created as part of the January challenge, which is a generative art challenge, I think taking place every year. The idea is to create some visual using generative techniques like code, given some pre-specified prompts or some ideas. And the prompt for this visual was to design a rug. And I combined it with another prompt from the day after, just to have a little bit less work, which is using a generative color palette. So I did both in this one. And yeah, for this tutorial, I thought it's a good learning exercise to recreate it so you can see all the different steps and thoughts and techniques behind the whole process here. And in the first part of the tutorial, we came until here that we created this mandala-looking, almost symmetrical shape. And in the second part, we now continue on creating more complex patterns and then also rearrange them in the final rug design, so to say. So the last thing we did in the first part was to create a polar coordinate transform to arrange some basic shapes in a circular fashion, so to say. And then we also introduced some kaleidoscopic function, which is iteratively changing the coordinate space to get some more complexity going on. So these are the two parts. I'm also going to put some comments here. Polar transform. And this is a very simple KIFS fractal. KIFS stands for kaleidoscopic iterated function system. Function. And the next steps we are doing is to actually get multiple instances of this pattern laid out in the manner that you repeat the pattern in both directions, like in the X and the Y direction, so we could have like a repeated pattern. And to do this, we can use the function which we used already in our repetition in the polar space. This fract function, which I explained in the previous episode, where you can break up space into multiple subspaces, and then this is basically doing a repetition. And we can reuse this trick also here. I'm gonna comment this one out because it's resizing the pattern, but we want to go with the original size. So to do this, we want to do it in both dimensions, so we can just use the whole vector p, which is going in both dimensions, and use the fract, just breaking up the space by returning us the fractional component of each dimension, x and y. And we also have to realign it to the center, so we have to subtract -0.5 to have the origin again in the center. And this is breaking up the space in 4 parts now, because we're just doing it once, and now we can also increase the size, the number of repetitions, by multiplying it by a bigger number, maybe times 10. And now you can see that we're already getting some something that looks like a tile kind of pattern, which is a good base for a rug, I would say. I don't know exactly what resolution I used in the beginning, but you can still see that there are some discontinuities on each border of the rug. So we might be able to change that by introducing some symmetry again. Yeah, something like this looks good. Maybe subtract something. Yeah, now you can see we are getting some more interesting patterns. Can also probably do something like this. Yeah, you can see where we are going from here. There's of course many ways to do that. Many configurations, so you can just play around with the parameters and see and look for something that you like. I will do this now for a bit and see. Yeah, this is maybe good. This is not doing anything. So we can see how it looks like if we do the polar transform before everything. Yeah, I think this is also something worth exploring. Maybe we even go with this one, because it's more kind of symmetrical. Oh, this one looks nice. So let's take this one. I think it's quite different from the original version I created, but I really like this. So let's proceed from here. And also something which we can do later, but just to show you how this actually works, if you want to do some animations. We can actually use our time variable, which is, if you have the play button pressed here, is increasing linear according to the time. It's called iTime. By the way, if you want to know which predefined variables you can use, you can click on this little bar up here and we'll pull down some definitions of variables. So these are all the variables which are defined by Shadertoy. It's called uniforms because it's variables that come from the outside into the program. And one we already use is the eye resolution, which is giving us the resolution in pixels of our current viewport. And another one we are going to use quite often, especially if we do animations, which is probably most of the time what we want to do, is this eye time variable, which is the playback time in seconds. And there are also other variables which we don't use so often. One thing is the eye channel, which is the things below here, which you can use for using images and textures. And there's also something like the date and a mouse input for further input, but we're not going to use any of those. But if you want to check it out, go check out the documentation of Shadertoy and some examples from the community how to use them. Now back to our pattern. Yeah, to add animation, we just have to add the eye time somewhere. And I like to put it in the rotation of this KIF function because it's always giving interesting effects, but of course you can put it also in different functions. It's always good to put it in something that is periodic. For example, this rotation is rotating all the time, so it's always repeating every 360 degrees, so it's something that is periodic. Otherwise you can also use a sine or cosine function to have periodic things going on. Because if you have a linear increase, you might move out of the viewport at some point, depending on what transformation you're doing. But here you see, okay, we get some quite fast action going on. We can decrease the resolution of the speed by just multiplying by the smaller value. Maybe something like this, 0.1 even. And then we have something very slow and subtle going on here. You can also see if we decrease the resolution even, something smaller. Yeah, something like this. Could be interesting. So much for that. I comment this out for now. Maybe just replace it by a 0 so it doesn't have any effect. And then we can plug it in later once we arrange everything. So yeah, it doesn't distract us too much from the rest of the design. So the next thing we want to do is to, now we have our pattern function, our basic pattern function. We might change it later, but just to give you a little bit of a roadmap what we want to do next. We're gonna use this function and reuse it a few times to layer multiple patterns with different resolutions. So to do this, we go back to our main function and we are going to copy and paste this. And let's say we want to decrease the resolution for the second one, have it a little bit more zoomed in, so to say. We can multiply it by a smaller number. So something like this is already doing something that's already looking quite interesting. But what we actually want to do is, like right now we have both colors added together. Like if you think in terms of Photoshop layers, we have a add blend mode, but instead we want to have a overblend mode so that all the colorful pixels of the second layer are going over the first layer and all the black pixels are treated as transparent. To do that, we can use our, let's say, this pattern value here, and then use it as a signal to mix both of the colors together. So let's see how this looks like. If you want to have a linear blend between two values, you can use a function called mix. It's basically doing a linear blend between a value A and a value B, and you give the value in the end, which is the X, and in this situation we want to let's see, we want to use the color, the previous color which is already defined, and blend it with a new color which is pattern times our color palette, and we want to use pattern as the inputs. This is not working. Oh, sorry. Mix, not mux, of course. And now I think this is what we aimed for. And you can't really see it right now because we color the output in the same way, so they are basically merged together. But if we use different color resolutions here, we can see that we get some different effects going on here. And yeah, this is already looking quite good. Maybe we want to have the coarse in the background and the fine in the foreground. So we might want to first do the 0.5, the more coarse resolution, and then the smaller resolution, the finer resolution after. So this is actually looking quite cool. And some other things we want to do, or I would like to do, is to have the color a little bit more symmetrical distributed. Right now you see there's just a linear gradient which is going back and forth in the x direction, but we want to have it more spread out from the center in all directions. So what we can do is to also use the y direction in our color palette as a signal for the color distribution. So we can just add uv x.y here, and I think we have to use a absolute on both sides, so we don't get this slanted pattern, but something that is more symmetrical. And yeah, this is already looking good for the first part. We're going to do the same also here in the second part. Of course, we want to multiply it by 0.2 or 1.5 maybe even. Yeah, something like this looks quite good. And of course, we can also animate all of that if you want to. Add a small fraction of our eye time, and you can see now the color is moving inwards, and if we subtract, then the color is moving outwards. So this is already quite cool. Something else I did for the color is, for the colorizing, something which you don't have to do, but in my original version that's how I played around with it. Let's use something like this so it has more contrast, is to have the color not distributed only like this, but also have the color distributed along the gradient of our distance function. So you have multiple layers of colors on one line, so to say. And that's one of the reasons why I decided to make the collapse of the distance function into the main functions. So we can actually use the raw distance function, which is our original gradient, to use this as a color input. And I just show you how it looks like in a second. I first gonna comment out this, so we're just gonna see it with one pattern, or maybe go for the first pattern, which is more coarse. Copy out this. So we have our gradient, our distance function here, and we can use this also as a color input, or as an input for the color computation. And this is not doing anything. I think I have to multiply it with a bigger number to have it any effect. Now you see that is creating a little bit more details here, because you get this kind of outlines, because now we also change the color not only in the directions of the UV of coordinates, of the screen space coordinates, but also in the direction of the gradient of our distance function. And to get a even higher, more details, like even multiple lines here, then we can also increase the resolution even more. But yeah, depending on what you want, this is not maybe something you want to do. But yeah, you can play around with this. Of course, the higher we make the resolutions, the more repetitions we have, and this will result also in less saturation, because it's more conversing to something white or grayish. So maybe something like 15 is good for here. Of course, we can also change the smoothness of our original function, so we can get even more patterns in the background. Now we get more of the original gradient, which is then colored according to this function. So maybe, yeah, depending what you like. Yeah, you can of course play around with this as you wish. So this is for the first gradient. Maybe for the second one we can do something similar. Have times 10 maybe added, and you can see we get even much more details and complexity going on here. Also can try to change this. Of course, this is losing a little bit of the saturation, so maybe we just stay with this for now. And of course, adding time, you can also animate it to get some interesting gradients going on. will deactivate the animation for now. So I think I'm gonna decrease this value a little bit. Yeah, I think this is already looking like a quite cool mandala kind of, maybe Indian kind of design. So it's a good base for an oriental carpet. So the next thing we want to do is to actually make a separate carpet of it. So sorry, I'm saying carpet here. I think that the correct version is actually rug. It just learned recently that there are different words, rug and carpet, and that the difference seems to be, at least to my understanding, I'm not natively an English speaker, but it seems that carpet is something which is covering the whole floor, and the rug is a more standalone floating piece that you may find in Moroccan markets also. So I don't know if that's correct, but that's according to what I found out. So maybe they can be used interchangeably, maybe not. But yeah, I go with the terminology of rug instead for now, which was also the term for the initial challenge. So yeah, to correct myself, I'm gonna create it in a way that we have a separate rug. So we want to have it not covering the whole screen, but just a square. So to do that, we're gonna multiply the output by some square, which is white in the foreground and black in the background, and we already have a square function, so we can just reuse that. And to have it white in the foreground, we have to inverse it, so subtract it from 1 and use a square. Use I think we called it rect function, and if you just joined this function is something we defined before. It's drawing a black and white rect. And some dimension, sorry, back 2. Let's say 0.6, 0.3, something like this. And because this is a distance function, we also want to use a smooth step around to create an edge again. And let's see how this looks like. Get an error. I think I spelled smooth step wrong. Yeah, that's it. And we don't see anything here. Just because I think we have to do the inversion after the smooth step. Yeah, that's it. And I think the dimension looks good. To have it a little bit more flexible, I think we're gonna use 2 pi 1 to have it 2 in one direction, 2 in the x and 1 in the height as our aspect ratio, and then we can multiply it by some number to increase it, decrease it. Oops. Maybe 3.5, something like this. Is good. And something else I did in the original version is to create something like a don't know what's it called, a rim or an edge around here, some more decorative element with a different pattern. And to do that, of course, we can use our rectangular function again. Let's define a variable for that, float edge, and use a something like this, but a little bit smaller as our dimension. And that's creating the distance for the edge, but we want to so now this is creating the distance to the rectangular, but we want to have this just the edge, so just have the outline. So we're gonna use the same trick than we used in our pattern function before with this absolute. So we say, let's say use D here and then define the edge. Just recycling variables here now. It's not maybe the best way to do. Maybe we can rename it edge D for edge distance, and then have the final edge as edge, and use abs edge D minus some small value. And then multiply it with the final color, and of course we need to use the smooth step here as well. Not have the gradient, but to have a defined edge. And yeah, this is really looking good. Something to what we wanted. You can see I reused the same dimension, but this is not looking so nice design wise, because now the distance here, the margin to the top is smaller than the margin to the left and the right, and we want to change that, so I'm gonna make it less height, I think, so we have to change the resolution here even a little bit, like something like this looks nice. Of course you can probably all compute this more accurately, but I just did it like just visually guessing what is a good value here, and this is fine for now. Now what we want to do is to add some details also within the black, our black edge now. And to do that, what I did in the original version was to reuse our circle function, but with a higher resolution, so we can actually create multiple circles. And we're gonna do this here as well. So now we want to add our color, the circles, but we only want to add the circles where we have our edge, but the edge here itself is black, where we want to have this outline edge, but to draw something here we want to inverse it. So we going to use this value, the inversion, as a mask, and then of course we want to draw something here, and we're gonna use the circle function. But with a higher resolution, maybe something like this, to create multiple circles. And the circle function also needs a radius. And of course this does not work because we are dealing with distance functions here, and we want to actually collapse it into a defined circle. So we also have to do the same procedure as we used to do. I put this into a circle distance, circle D, call it circles D because we want to have multiple circles, and then get our actual circles. As a using the smooth step. Again, it's always the same here. There's no actual change to the procedures how we did it before. Circles D, and then we can use this here just to see how it looks like. And this is not doing anything, and I'm not sure why that is. I think it might be okay, maybe I have some error in my thinking here. But something I also forgot is that we want to just have the outlines of the circle, so maybe this will fix the issue. Circles D. But it does not. And let's see how it looks like. It's completely white. Of course, we have to invert it. That was what was missing. And there's also an issue with here because you want to repeat it, so we actually also have to use the fract function here. And now because we have to realign the coordinates to the center, and now we should actually have some circuits going on here, and we can now change the distance between the circles by increasing the radius, and also change the resolution by increasing this multiplier here. And what I try to do it as such is that the circles line out perfectly within the black frame. So I'm just gonna play around with the numbers to see, find something that is fitting. Something like that maybe. No, it's aligning with the bottom parts, but not with the left and the side parts. So we maybe just change slightly the resolution of the frame itself to fix that. So maybe have that a little bit bigger, or smaller, yeah, something like this. Maybe looks good. Maybe increase the size a little bit. Yeah, I think something like this looks good. And now we want to add also a little bit more details on the circle. So one thing we can do is to actually use this absolute function a second time, which will create another circle in the center. So I think, as I showed you in the last part, we can nest those these onion functions, how we call them, to have more onion layers, more concentric onion layers. And we have to play a little bit around with the values to make it look good. Now we have like two very fine circles, but what I want to do is to have a higher resolution and higher thickness in total. So we can increase the first value and then also increase the second value to something. Point 4 maybe is good. Yeah, I think that's something that looks nice. And of course we want to color them as well, and we can add the color here using our palette function again. And what I like to do here is also use the distance function, the original distance functions, as a color input. So circles D. Multiplied by a higher value. No, it's not doing anything, or maybe by a smaller value. I see this is not what I actually wanted, because I want to have the original one before we do the onion. So we somehow have to save that value. Let's create a new variable here, float distance D1. and then use this one as the original one. Okay, this looks great already. Let's see how it looks like. Let's just play around. Yeah, like this we get a little bit more funky values, but I think I just like it to have the inner circle in a different color than the outer circle. So ×2 is good. And then play a little bit around. The values here. Maybe this is just fine too. Oops. Yeah, let's leave it like that. Of course, you can play around with it endlessly. You can also animate it to have the color changing, get some funky psychedelic looking effect. We're also not gonna do this. What we might want to do, however, is also to change the color according to the screen space resolution, just to see how this looks like. So use the absolute of our Y or our X coordinate. Again, maybe a smaller resolution. Oops. Oh, of course, here it's called UV, not P. Maybe just very subtle change, so it merges a little bit better with the rest. And yeah, now we are almost done with our rug. A few more details I added in the original version is to create also an outline around this edge frame here, and also around the outer frame, just to have it a little bit more defined. So we can do this here, and I think what I did was to use the original distance function of the edge and use this absolute function to create an outer edge. I don't know exactly which values I use, but I will try to, yeah, let's play around. HD Let's use the smooth step again. We want to do this onion a second time. is not doing it. Yeah, now we're getting there. So what I did is use the original onion here. I could also have put this in another variable here. Maybe I do this real quick. So I can spare the computation again here. And then do another onion around it, so to say, to get an outline of the outline, so to say. So HD. And I think what we can do is also to increase it a little bit so it's not touching the circles. I think we can do this by adding or subtracting a small value here. And I think this is something that looks good. Have it even a little bit bigger. Yeah, I think this looks good. And now this is white, but we also want to color it. So we're gonna multiply the whole value by some color. Can just copy and paste what we did here. Now I'm having some issues with parentheses. I think I'm missing one here. Yeah, there we go. And you see this is just adding the color, but of course we want to overlay the color and not add it. So what we need to do here is to use this value again to mix it in. So I put this in another variable, float, how we name it, outline, edge outline. So we say mix our original color with our overlay color, edge outline times the color value, and we want to use the outline color as a edge, as a mix value, and voila, this is doing the trick quite beautifully. You could also change the colors if you like. Something like yeah, let's go with this orangey yellowish gradient. And we can also do the same trick for the outline of the whole rug. And to do that, first I think I want to fix a little bit the dimensions, because now see that it doesn't line up visually very nice because the margins are different on both sides. So you want to increase the height of the whole carpet a little bit. Yeah, I think something like this. It looks good. And I'm gonna put this in a variable so we can reuse it. Color, no. Work, rect. Just use it, work. And now we can actually just copy and paste this whole outline function here. Make a float rock outline. I'm gonna copy paste this code here. Put in the rock. Let's see if this makes sense. Yeah, this looks quite good. So I think we are almost done here. The only thing I want to add now is some animations. And one animations I did in the original version is to animate the whole rug, so it's kind of floating a little bit, like a flying rug also. And we can do this quite easily by transforming the input coordinates, our whole UVs, with some sine function. So we want to add it in a way that we change the x with the sine functions of the y and the y with the sine of the x, so to say. So we want to use a sine and reverse the coordinates to yx, and of course also animate it. This is probably gonna give quite a lot distortion, so we have to decrease this by a smaller value. And now this is already looking okayish, but we want to have it a little bit more higher frequency wiggle, so we can multiply this input by a larger number, something like this. Maybe increase the speed a little bit, and maybe even decrease this some more. Even 3. Yeah, I think something like this looks nice. And last but not least, we can also animate the input, the pattern itself. And to do this, we already have it defined here. We can increase our time speed. And now we have our magic flying carpet. So I will leave it here for now. I hope you enjoyed the tutorial and learned something cool and useful. If you have any questions or feedback or Any interesting topics you would like me to cover in the future, please let me know in the comments. And I will also put up a link to a Patreon page where you can become a member and support me and get early access to future videos and some additional in-depth materials in the future. And yeah, also if you haven't already, please like and subscribe, and see you for the next tutorial.